Hello, everyone. I hope you all are having a good day here. This is Dr. Bachnight coming at you with another week of uh, exciting environmental science stuff, right? So let's see. I have done this week. Is this week 4, I believe? Let's see. Yeah, week 4. We're going to talk about ecology of communities, species interactions, keystone species. Some of my favorite species. I love them. They rock, man. We'll talk about biomes as well. Another thing I really like to enjoy about. If you know the temperature and precipitation, you know what's going to live there. And remember, next week we are going to jump all the way to chapter 14 to get right into current events or get into climate change. All right. So we're going to kind of skip over a couple chapters. And then I added week 6 here. In week 6, we're going to come right back around and come back to chapter 5 from the required text. And that is on economics, policy, and sustainable development. So we kind of went through all these uh, natural forces that we kind of have to abide by due to laws of nature. And economics and all this stuff kind of says, hey, how do we apply those to our ethics? How do we want to use these to our advantage or not use these to our advantage? That's what governmental policy covers. So that is week 6. But please note too that on week 6, I don't have you doing a current event, okay, for your Wednesday assignment. I'm going to have you do this Crazy Town podcast. So I want you to download this little doc here, and it's just, I think, 10 questions, right, for that. And then you can go to Crazy Town and go to the link and listen to the podcast, okay? Or you can go through Apple or whatever. It is going to be episode 2, punching Ronnie in the mouth. All right, and no one punches anybody in the mouth. They're being sarcastic. Okay, the guy is not alive anymore, so you can't punch him in the mouth. All right, but I think you'll get the gist. Sometimes I want to punch some people too, but no harm is really meant to Ronald Reagan. It's kind of the growth thing. Okay, and then later on we're going to listen to a couple more too. We're going to listen to this 1.21 gigawatts, and we're also going to listen to Solar Freaking Roadways. All right. So, but this is a good podcast from the Post Carbon Institute. So that's what we're going to do instead of the current event on that day. All right. So let's hopefully we got that all straightened out. And we know where we're at. So we got all the way up to week 6 here. So, but this is week 4. And in week 4, we are doing ecology and communities. All right. And the case study of this one, it's one of my favorite. I can't say my favorite case study. It's kind of a shameful case study. It is about the battling of Asian carp. And we talked a little bit about animals becoming extinction last chapter. And one of the ways they come extinct is due to an invasive species comes in and they outcompete them and take over the ecological niche. And these Asian carp, man, it has become a big, big, big problem because we can't really drain the Mississippi and kill all these Asian carp. And they are starting to get close to the Great Lakes, and we're getting in trouble. We're getting really, really scared. All right. So let's check out this little video about battling the Cajun art of carp before we start into chapter 4 here. Ooh, spooky music, huh? Do-do-do-do-do. It's like Friday the 13th. Freddy's coming for you. But it's also sad. I never had them. I don't know. I don't eat too much fish.
We've been in
Ouch.
business since 1955. Sales-wise, we handle over 20 million pounds of fish a year. We're all freshwater fish from the Mississippi and Illinois River and lakes out of Minnesota and Wisconsin. In the Great Flood of '93, when the dikes broke in Mississippi and Arkansas, large numbers of these fish were released into the river systems.
We used to use them for ponds to keep away the
We have a
algae.
lot of small Asian carp not very far from here, within 20 miles of here. They are definitely migrating. Last year we handled over 12 million pounds of Asian carp alone. It's readily available 52 weeks a year to our customers.
These carp are able to eat a lot per day, probably 40% of their body weight, and they eat plankton. But it's a food source for many fish. And so by reproducing very rapidly, they're able to overpopulate in an area and really crowd out the other fish. This right here, Curse the Current, more than 40 of these beams all the way across the bottom of the canal. The width of the canal is 160 feet. We are able to create electrical field inside of the canal, while at the same time allowing navigation. And as fish approach from downstream into the electrical field, initially they just feel a little tingle. And if they continue to try to come through the electrical field, it's stronger. At some point, most fish will be stunned and float back downstream. And this is 33 miles away from Lake Michigan. So this is one tool only though, and this is one location.
So to stop them, they set
We've
up
got
an electric
20
fence.
years. Been here for 3 years now, here at the Palmer House, about 1 block away from Lake Michigan. We're trying to keep Asian carp out of the lake, and I'm trying to do my small part by putting them on our menu and trying to keep them out of existence.
Let's go. Let's eat them out of
What we're
existence.
doing is we're starting here with a little bit of olive oil,
Let's collapse that
add some
fishery.
garlic to it, add a little bit of tomato sauce to that. Just today, for the first time, we got in a minced product from Schaefer Fisheries, so we're just going to add that in. Asian carp, Shanghai bass, bolognese may not sell very well, but then you call it a seafood bolognese, and we might be onto something. If this fish does get into the Great Lakes, if it continues to destroy the water system as it has, we better look into making a market for this thing as a food source now. Once again, trying to bring you a community service by putting Asian carp onto your plate.
So maybe next time you're watching the Food Network,
That's good job.
you will see a
Three.
little Asian carp stuff going on. So we can eat some more of that. All right. But this Asian carp stuff has been a big, 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 big problem. All right. And we'll talk about that in just a second here. Let's get over the lecture um, bullet points first. Ugh, come on. Nope, I'm already on. Okay. So this lecture, we're going to talk about species interaction, feeding, relationships, energy flow of the trophic levels, food webs. We'll talk about keystone species, succession, potential impacts of invasive species, and what's called restoration ecology, and all the different terrestrial biomes we got out there, folks. All right. So the case study is about this Asian carp. All right. Um, Leading fish backward river Asian carp threaten the Great Lakes. All right, so back in the 1960s, 1970s, we used these catfish farms. We had these catfish farms. We used these Asian carps to take care of all the algae and stuff. They're great, man. They just eat it up, but they come from Asia. That's why they're called Asian carps. Okay. And they were super about eating the algae and the snails. And some of these individuals escaped into nearby streams and rivers and ponds and lakes. All right. And due to the Great Flood was the biggest onslaught, but there was also other ponds that were flooded before that. And the Asian carp has been very successful, growing too large for its predators to capture and spreading out through the Mississippi and Mississippi River Valley. And it's making its way slowly but surely up north because it doesn't like salt water. Okay, but it's getting warmer, so it's going up north. into the Great Lakes. And if it gets into the Great Lakes, it is, you know, timeout. There ain't no way we're going to be able to stop it. That is just huge because, like most, you know, remember carrying capacity is the certain given area, a land area or mass, and its biological capacity to be able to hold one individual population. So the Mississippi River is kind of small, right, compared to the Great Lakes. And just imagine if the Great Lakes, that size of the population that Lake Michigan could handle with all of its food and no competitive, no predators or anything else. I mean, that population would just boom, and it will be game over for the Great Lakes. So he put up this electrical barrier, like that guy was talking about. Okay, so when they are swimming up here, they get fried. All right, and we don't try to kill them all. You know, we give them that warning. Like I said, it's slowly but surely until finally they get zapped and float back downstream. Okay, but this is also a disadvantage because it blocks off not only the carp, but there's other ones that go back and forth that swim. I mean, it's just not always land animals, right? So these some fish in Lake Michigan will come back up here and do their egg laying, and then come back out here and do their thing, and come back here and do their thing, come back there. You know, they're back and forth. It's a two-way street. Okay. But this electric barrier has to be done to stop them. If we don't, if they get into Lake Michigan, it is game over. The Great Lakes have always been become host to invasive species. There's over 180 non-native species, and another one is the zebra mussel. All right, and a zebra mussel was introduced because it clung on to the ship's ballast in the water of ships and caused hundreds of millions of dollars of damage. Or it went onto the ballast and got transferred into the Great Lakes. Okay, and now that the population's there, if you leave your boat in the water, which didn't have these zebra mussels, they attach to the ballast, and now everybody has to get their boats cleaned due to those zebra mussels on the boats, and it's causing hundreds of millions of dollars in damage, and also clogging pipes around there, covering boat propellers, outcompeting native mussels because it's an invasive species, it has no native predator, and it's eating the same thing as the other mussels, and it's transforming the fisheries like we've never seen. Okay, you add in a new dominant species into an ecosystem, guess what's going to happen? That ecosystem's going to change. Okay, so what further impacts could the Asian carp have on the Great Lakes? This question requires knowledge of how each of the population of the Great Lakes interact with each other. All right, it's not just a matter of trying to get them out. We need to try to overcome this problem using Mother Nature instead of draining out the Great Lakes, because we can't drain out the Great Lakes. So we're going to have to try to watch Mother Nature and figure out how Mother Nature would solve it if we're going to solve it. Do we know that solution right now? No, we don't. Okay. But right now we're just on preventive med. We're playing defense. We're trying to prevent them from going into the Great Lakes. But I believe I saw an article about some carp showing up in the Great Lakes, so it might already have happened. Okay, you can look that up for one of your current events or something for me. See if I was right or not. Can't remember if I saw that. So species interaction. Ecologists organize species interactions into main categories, and you guys should all know this kind of stuff, right? We have the competition, where the two species are competing against each other, and we don't know who's going to win or who's going to lose, but it's usually negative on both sides because you're going to get hurt. It's going to take some energy to outcompete the other person, all right? But the person that loses definitely loses the most, okay? Then we have what's called predators, parasites, and herbivores, all right? And these have one benefits and one is a negative, okay? So the predator gets the prey dies, that's the negative. Okay, parasite COVID gets onto us and hurts us, and that is the negative. And then there's also mutualism, Well, both things coincide together. And we'll see a little tree with I think I have a picture here of a tree with a little plant on the bottom. They kind of work together. Or you see the oxen out there in Africa where they have that bird on the back and it's eating the ticks off its back. Okay. We got this bacteria in our gut that allows us to digest our food. That's the two species are interacting together. Our stomach is protection for that I guess what do you want to call it, the parasite. It's not a parasite. It's just something else breaks. It's another single-celled organism that lives inside of us. Okay, that name just disappeared from my head. Organisms that seek the same resources have relation called competition. Okay, so that's what competition is. We're trying to, everybody wants a new cell phone, new Apple Watch coming out or whatever. I'm keeping out, and I'm gonna beat you to the punch. Right. So that is always competition, going after the same resource. And there's what's called intra-specific intra-specific competition, and then there's intra-specific competition. Intra-specific competition is between the same members of the species. Me and you, baby. We're going head to head. All right. And inter-specific competition is between members of different species. We're going head to head with the deer. We want to be able to have our suburbs, and the deer want their woods back. Okay. Competition becomes more intense when populations are dense, right? When two populations of different species get together and they're competing over the same resources, they're going to have more competition, and the battles are going to ensue in that area when there's a lot bigger of a population till someone wins. Okay, that's just the nature of the beast. Okay, when two teams get together and play a football team, the competition seems to increase as the crowd gathers in that football stadium, right? Well, over many generations, though, natural selections may favor what's called resource partitioning. Remember, we talked about Charles Darwin and the origin of the species. He talks about survival of the fittest about 3 or 4 times in that book. It talks about love and cooperation about 100. All right? And this resource partitioning is some of that cooperation he talks about, but it's also Mother Nature. All right? So, with a good mutation in the animal. So the woodpecker, all right, it is all these birds are sharing the same tree. Okay, the woodpecker is able to go inside. The white-breasted nut climbs down the truck looking for the insects. Okay, the woodpecker, the yellow-bellied woodpecker, drills rows of holes. Okay, the brown creeper climbs the trunk looking for tiny little insects. All right, they're all using the tree, all right, and sharing the resource, but all have a different way of getting what they need out of it. All right, and this is also a way when they breed too, or nest. You'll see a saying like the finches. They're amazing little birds. They have a pine tree right here, and some will stay at top, some will stay in the bottom. Another species of the finch would be in the middle. All right. Some of the finches will live on the outskirts of the tree. It's amazing how they partition the tree. So cooperation, resource partitioning. Species interaction and competitive interactions, each participant negatively affects the other by taking the resource. All right. So competitive interaction, each participant gets hurt negatively. All right. In other types of interactions, some participants will benefit while others will be harmed. So predation is a process by which individuals of one species, the predator, capture, kill, or consume individuals other than the prey. So the Asian carp were introduced to prey on algae and snails. That's why we got them. We wanted to be able to clean those ponds. Little did we know that they were crazy and can just jump like crazy when a boat goes by nowadays. Okay? But predation is the process in which individuals of one species capture, kill, or consume. So the thing that they're eating has to be alive, and that predation doesn't have to, be constrained to the lion or tiger or bear. Okay. Also, the bug that eating the leaf is consuming the leaf of the tomato plant, and it is also a predator. So keep that in mind. Predators that are often better at capturing prey will live longer than the ones reproducing, and this is called natural selection. And will favor adaptations that enhance hunting. Okay, the cheetah, right, will get faster and faster chasing after that kudu. The prey have the risk of death as selective pressure, causing the evolution of many types of defenses. So the kudu and the cheetah was able to, get faster and faster off the get-go and get to that kudu. The kudu was able to outrun and outlast endurance, the cheetah. So it can go at a top speed for a lot farther, and that's its defense. And also it herded up and things like that. All right. Parasitism is the relationship where one organism depends on the other for nourishment. All right. So parasites, unlike predators, usually don't result in the organism's death. They're still predators in a sense. All right. But they don't kill off their host, because if they killed off the host, they wouldn't be able to survive anymore. So parasites live within the host in many different ways. All right. Inside the host, such as a tapeworm, on the host exterior, such as sea lampreys, or living or free living, such as the cockatoos, who will lay their eggs in another species nest and have that other species hatch the egg for them. Right? So they're pawning off their parasite pawning off the parental duties to another species. So parasites can cause disease, and we call these pathogens. Okay, so there are some parasites that don't hurt others. All right, and there's many parasites that actually do. That's what we're used to hearing, the parasites that causes pathogens. The pathogens can get us sick, like malaria, tuberculosis, hepatitis. Okay, these are all parasites. And parasites and hosts adapt and counter-adapt to each other through a process called coevolution. So the duel of escalating adaptation between parasites and hosts is known as the evolutionary arms race, right? So the parasites wants to knock us off, and we want to be able to defend against that parasite. And it's an ongoing battle in nature, okay? The COVID is, a new strain of virus to us, all right? But it's not unusual for a parasite to jump over from one species, from one species to another. I'm sure you've all heard of this swine flu. Okay, that comes from the swine, from the pigs. I'm sure you've heard of the avian flu before. That is a strain of flu that jumped over from the birds. All right, so COVID is not a strange and a strange happening in the world. Okay, it is part of the evolutionary arms race out there. All right. There's also herbivorization, and remember that this is a form of predation. So the herbivores out there are actually preying on the plants, right? And insects, of course, are the most common types of herbivores out there. Plants have also evolved defenses, such as toxic chemical thorns and spines and irritating hairs to fend off the people that want to eat them, right? And one of my favorite ways that nature works together is called mutualism. All right, each one helps out each other. All right, mutualism is a relationship where two or more species benefit from each other. The relationship occurs between species is called symbiosis. All right, a close physical association between species. We have that symbiosis with that bacteria in our stomach that helps us eat. All right. The symbiosis, mutualism of this flower, certain flute-shaped flower cone, and the bill of the monkey or the hummingbird is able to get in there. So you'll see hummingbirds always go after these wide trumpet kind of looking flowers where they can get in there. right, like hostas and things like that. Other relationships such as in pollination, birds and insects transfer the pollen to the other flowers. So community is defined as the assemblage of population of organizations living in the same area at the same time. All right. So once again, we have to have a defined area, right? And it's all the different populations of the different organizations living here at the same time. So community ecologists study the species, which species coexist, how they interact, and how communities change over time, and why these patterns occur. All right, so we have, as a community ecologist, you sit there and watch everything, all right, and see how the deer and the antelope play together, all right. And then you can come up with these models and predict what's going to happen in the future, or what would happen if we had a disaster, or if this population was taken out, or what happened to the deer was taken out, or what happened to the antelope, who would they have to play with. Okay. Some of the most important interactions among community members involves who eats who, though. Okay. And this is called the food chain, right? So species in a community are given a rank within feeding hierarchies called the trophic levels. Fancy dancy name for the food, what level of the food chain you live on. All right. But first of all, the most important thing, we wouldn't have a food chain if we didn't have producers. All right. If we didn't have photosynthesis or chemosynthesis, all right, chemosynthesis is in those vents down there in the bottom of the ocean. Photosynthesis is the plants up here on terrestrial land. All right, and that's what we're mostly interested in, because I don't know if those tubers, I want those tubers taste as good as the fish. But we don't have a problem with those tubers down there in the bottom of the ocean, do we? So the primary producers, all right, are the plants, right? And without them, we wouldn't have any other food, because they magically take the sunlight up there in the sun that's shining down and turn it into chemical energy for us to consume, right? And without that chemical energy, we would not be able to live. Yes, a cow might be able to eat that chemical energy, and then we eat the cow, but it's still coming from the ability of the producers to use photosynthesis, take sunlight and store it into chemical energy for us to use later in its bodies. And then we have what's called the primary consumers, which consume the producers. All right, so you got the producers down here making everything, the plankton for the seas, all right, and the plants, okay. And then the primary consumers will basically be the insects, basically. All right, and then we have the secondary where we kind of go up. We got the chipmunk and the owl, and then you got the hawks, which are the tertiary consumers, which are the top level, right, predators of the food chain there. But then we also have, we got to remember, we have what's called the detrivores, which are the scavengers, and they waste of the dead bodies, because all these things are preying on live biological species. All right. So the grasshopper's eating a live plant. All right, but the plant's on sunlight, so that's all it gets. Okay, right? And then the rodent's eating the grasshopper, and then the owl's eating the hawk, but they're all alive. The decomposers or detrivores savage all the waste of the dead body. So they go after these dead rodents that fall. All right, we have what's called the vulture turkey around here. All right, that eats all those big dead bodies. And then you have the decomposers, which break down the non-living matter into smaller molecules. So the detrivores will mess it up a little bit, then the decomposers will finish it off. And these play an especially important role in cycling the nutrients back into the soil for the use of the plants, all right? Because as they break these down, it gets that carbon and the nitrogen and all that stuff into its original form of matter, so the plants can now take it up and get some more energy, okay? It is your Mother Nature finishers, like worms. So they are Mother Nature's finishers. Okay, there's the earthworms out there. They finish off everything and put it. It's like a perfect solution for the plants to take it up, and it just completes the cycle, the life cycle. All the carbon molecules are just fall from going around in that big old cycle. So a carbon dioxide's out there in the atmosphere, or a tree sucks it up, right? Puts it into its trunk, right? And into a leaf, and then a grasshopper comes over and eats part of that leaf, okay? And then the rodent actually eats the grasshopper, okay? And then the hawk eats um, the rodent, okay? And eventually the hawk dies, okay? And turkey vulture swoops down and starts eating the hawk a little bit, and then the decomposers, the worms, and the mushrooms take over and break it down even further so that the plant can take that carbon molecule back up in through themselves and start the process over again. Nothing is wasted in Mother Nature. Okay? Nothing is wasted. But the one problem is at each tropic level, most of the energy input is either used for the maintenance or is lost in heat. So a tropic level will have about 10% of its energy content organisms and biomass compared to the lower level. So we lose a little bit. So the primary producers has 1,000 energy calories, right? Well, the grasshoppers only have 1, and then 10, and 2, 1 down here. All right, so we lose a little bit of energy as we go up into the tropic levels. So biomass is the collective mass of all living matter given in any place and time. So the pyramid pattern of the energy of the biomass illustrates why eating lower on the tropic levels can decrease your ecological footprint, because it's going to take less energy to get all this stuff out than it is to get to be the hawk up here. Okay, and that's why your ecological footprint actually drops. And we'll learn a little bit more about this also in the agricultural section. Okay. So the flow of energy and feeding relationships from lower to higher levels is depicted in the food chain, and food webs incorporate all the interlinking of the food community. And the Asian carp are predicted to affect the Lake Erie food web by decreasing all the biomass by eating the plankton, all right? And then all the other predators or all the other fish that eat the plankton won't be around, and the predators that eat that fish that eat the plankton will start dying, all right? And while increasing the biomass of the fish that use the juvenile carp to prey for. So they're still gonna, the juvenile carp, they grow so fast and get so big, they can make it to adulthood a lot faster, right? And then they have a case, what's called a K population strategies. They have thousands of kids, right? But nothing's out there eating the juvies, okay? So the food web is just, the feeding relationship and the energy flow throughout the whole chain, right? And I'm sure you've all seen the food web with the dictivores down here breaking everything down so the tree can break it on up, and then the caterpillar eventually eats the tree, and then the caterpillar gets eaten by the bird, and then the bird gets eaten by, I don't know, wolf somewhere around here or something like that, fox, okay? And it finally dies down and goes back into the soil and back up. So the food web helps out each different, it's just a flow of energy throughout Mother Nature. So let us stop here, I think, and we will get into my favorite topic next time, keystone species, and then we'll start talking about the biomes, I believe, all right, after that. All right, so let us stop here, and then we'll put up another video on Thursday and finish off this chapter. How's that sound? Okay. So if anybody has any questions, just let me know, and I will be glad to answer them. I'm still grading through your paper slowly but surely. I'm getting to your homeworks. Hopefully you guys will see them popping up. Okay. Thank you very much, and have a good day, everybody.